Good day, everyone, and today we will be talking about our supposed first topic for the midterms, which will be amino acids. So, amino acids, there are 20 current and in literature amino acids that are present in proteins, which means that your proteins are basically comprised of amino acids. And in the current book of Harper's, these 20 amino acids are classified further into their specific identifiers so that you will be able to easily understand how their functions are and for you to memorize how and for you to easily memorize how they are separated in. So amino acids provide the monomer units of long polypeptide chains, and they participate in cellular functions as diverse as neurotransmission, such as your tyrosine and tryptophan, which are precursors of your of your neurotransmitters, synthesis of your purines, your pyrimidines, and your urea. So, amino acids may either have a positive, a negative, or a net zero charge. In aqueous solutions, the charges or the charged and uncharged forms of ionizable weak acid groups of COOH and NH3 exist in a dynamic protonic equilibrium, which means that in aqueous solutions, it can either be charged or uncharged forms or even exist in dynamic protonic equilibrium. So it can be charged, negatively charged, or even have a net zero charge. To basically or to easily demonstrate what I mean is that we have the term Zwitter ions. In Harper's, there are molecules that contain an equal amount or equal number of positively and negatively charged groups which bear no net charge in totality, because it's basically your negative charge or your positive charges and your negative charges negating each other, therefore causing a zero net charge. Zwitter ions can form from other molecules called amphalites or amphoteric compounds and can act as both an acid and a base. In neutral pH values, the amino group NH3 has a positive charge and the carboxyl group has a negative charge. Both terminus, sorry, not this one, but this one, both terminus contributes to what the finality of the charge of the Zwitter ion might be. So Zwitter ions are dependent of pH. A Zwitter ion isn't always a Zwitter ion. At pH values far below or far beyond 7, which is the neutral pH, its group can take different charges or become neutral. At low or acidic pH, pH or in it's lower than pH 7 is considered acidic. The hydrogen ion adds to the carboxyl group, making it neutral. This gives the amino acid a net charge of +1. So, if the amino acid is present in a pH or an acidic solution, for example, the solution is acidic, the net charge of your of your amino acid or your Zwitter ion would be positive. Why? Because the H plus, the positive ions here, as in literature, dissociates to the carboxyl group, rendering it positively charged. Diba? Kaya mo ito siya kaginaang negative COOH. Okay? So the H here will go here and it will render this neutral, which would leave the NH3 positive group NH3 positive group present, meaning it will render it positive. However, at high or basic pH values, or in the values are greater than pH 7, the hydrogen ion on N is removed by the excess base, neutralizing the amino group. This gives the amino acid a net charge of negative 1. So here naman niya, wherein you have an OH from your basic, it will counteract with the positive ion from the NH3. So this will be counteracted, which will only leave you with your COOH or your carboxyl having a negative charge. So the net charge is now negative. So at low pH, the charges will be positive of your Zwitter ions, and at high pH, the Zwitter ions will be charged negative. So it depends on the solution of where your amino acid will be or your Zwitter ions will be, and that will determine the charge that will be occupied or that will be present in your Zwitter ion. We have now two classifications of amino acids, the essential and the non-essential amino acids. Essential amino acids are not made inside the body, therefore they are usually taken in from the diet. Amo na silang gina-supply, or these are the ones that are supplied or supplements in milk, in vitamins, in your food supplements. These are the ones that are added because our body does not have the biological or the biochemical processes to produce these. In contrast, we have non-essential amino acids which are naturally present in the body and does not need to be taken down or to be taken from exogenous sources. So meaning these are already present in the body. Meaning there are biochemical reactions that are happening inside the body which can produce your non-essential amino acids. It's important that you memorize the essential amino acids, and our mnemonic for this is private Tim Hall. Okay, so that's phenylalanine, valine, threonine, tryptophan, isoleucine, methionine, histidine. Then we have leucine and lysine. The A here pala is not present. It's just private Tim Hall. We assume that it's Hall because histidine and LL. Basta mo na siya. That's how we remember them. So if you have your own mnemonic, it's much better for you to use them. Now we classify amino acids with their aliphatic side chains containing hydroxylic groups, side chain containing sulfur atoms, acidic groups, basic groups, aromatic rings, and your amino acid, which is only proline. So with aliphatic side chains, in amino acids, when making amino acids or making protein sequences in biochemistry, you have to remember that protein sequences or your proteins are actually made up of numerous amino acids, and it will be very, very hard for us to identify or to write the amino acid structure of these proteins one by one. So for example, your hemoglobin is more than 100 chains of amino acids, of different amino acids. So we have to write them down pagid 100 times, and that would be very hard. That's why we have the 3-letter nomenclature and the 1-letter nomenclature that has been devised for us to easily identify or for us to easily write down the amino acids that are indicated. So for those with aliphatic side chains, I will leave you to it to memorize this one, but I will teach you on the different amino acids that can easily be memorized with their one letter or 3-letter nomenclature. So glycine, its 3-letter nomenclature is GLY, 1-letter nomenclature is G. So basically, this one you will not have any problem because it's G, A, V, L, and I. Here, since side chains with the hydroxylic group with the OH at their side, we have serine S, threonine THR T, and tyrosine. Notice that tyrosine and threonine both have letter T. That is why tyrosine cannot use T anymore. That is why it's going to take its second letter, the Y, in tyrosine, and use Y as its 1-letter nomenclature. So if I will ask you, identify the amino acid given the structure, it's GASYT. Your answer would be glycine, alanine, serine, tyrosine, and threonine. If you are to write it in their three-letter nomenclature, it will be GLY separated with the dash, ALA separated with the dash, SER, TYR, and THR. If we're going to write the whole name, we should separate them with the dash, and using a three-letter nomenclature, we should also separate them with the dash. But if we're only going to use the one-letter nomenclature, there is no need for a dash. Okay, so that's how you do it. Next, we have here the aspartic acid or aspartate, which the first or the three-letter nomenclature is ASP, and the one-letter nomenclature is D. Next is asparagine. You just have to remember asparagine with the letter N at the end. So its one-letter nomenclature is letter N. Glutamic acid, glutamic acid, one-letter nomenclature is E. And glutamine, its three-letter nomenclature is GAN, and its one-letter nomenclature is Q. Because what was taught to us before is that sometimes when they pronounce glutamine, they pronounce the G as a Q. Because kung laton siya ang G kagang L, kung gin-mix na before, hambala man isa mo ni Miss Class before, isang gina-write na siya daw, like gaka-miss-write ang G and L, like gakatapik sila, which makes it a letter Q. That's why its one-letter nomenclature is letter Q. Sometimes these scientists also make mistakes, so that is why may at times nga mga ginasulat nila, do wala na gidlabot, pero kay amo na siya nasulat, hindi na siya ma-change. So just take note of that one. Next, arginine R. Arginine R. Lysine, LYS. What's after L? HIJK. What's before L? That's K. So that's why it's letter K. Histidine, His, and H. So, histidine is basic. At the same time, it contains an aromatic ring. So, phenylalanine, you just have to sound it out. Phenylalanine, it's F. Tyrosine, that's Y. Tyrosine has been present a while ago in those with OH, hydroxyl groups. And next is tryptophan with its three-letter nomenclature 3. TRP rather, and its one-letter nomenclature W. Panumdumon nyo lang ang pitla nyo nga friend nga mag-pronounce ang R nga ga W. So it's tryptophan. So it's letter W. And lastly, you have our amino acid proline, which is the only amino acid that's also an amino acid. So here are your 20 LA amino acids. You just have to memorize them. I got it from the book. You just have to take note of them in the book. What's coming out in the exam are mostly the nomenclature. So you have to memorize the table and identify what amino acids will be if I give you a one-letter nomenclature, or what will be the one-letter nomenclature if I give you the entire amino acid sequence. Then you also have to take note of this table, which are the hydrophilic and which are the hydrophobic amino acids. And at the center of each amino acid is a carbon called the alpha carbon, and it is attached to 4 groups: the hydrogen group, the carboxyl group, the amine group, and the R group, which is your side chain. That is where they differ, or this is where they classify your amino acids. So that will be all for amino acids. Thank you very much.